Welcome back to Mathematics Lifeline. Today, I want to talk about some derivatives that are really crucial to know before you get into all these new rules. So I've talked before about the power rule, and I've talked about how to solve a derivative as is, but a lot of the times you're going to have functions that you really just need to know the derivative of. And in order to do rules like the product rule, the chain rule, it's going to make your life so much easier if you understand some of these basic derivatives. So we know that if we have the derivative of, let's say, x squared, we can solve that being 2x. We can use the power rule to do that. But there are functions like, let's say, sine of x. Well, we want the derivative of that. Well, we can't use the power rule. And you'll find out soon we can't use any of the other rules that we have. So what are we going to have to do? Well, the real way that we found this derivative out was by graphing the derivative and the function, but that's something that I'll have to get into a little bit later. This is one of those derivatives that you just want to know by memory. So the derivative of sine x is always going to be equal to cosine x. So d dx of sine x is cosine x. So it's really important to know all of these trig ones. So I'm going to go through those real quick. Let's say the cosine of x. Again, we found this out by graphing the derivative graph compared to the function graph of it. And again, I'll go over that later. But this right here is just negative sine of x. Now we know that we have a tangent that we need to figure out. Tangent x. This one is equal to secant squared x. So those are all of our regular basic trig functions. Now we can do their counterparts, so we can also do cosecant of x. This is equal to negative cosecant of x times cotangent of x. Now for cosine, we know that that correlates to secant x. This right here is secant x tangent x. Secant x times tangent x. And then one more, we have cotangent of x is equal to negative cosecant squared of x. Now, I know this is a lot right now. It looks like it's really complex. There's nothing that you need to do other than memorize these. You can commit these to memory and you'll understand them pretty easily. Now, really the super important ones to know are going to be your sine and cosine. Because any of these right here, later when you learn the quotient rule, you can learn the derivative because this is 1 over sine of x. So we know that cosecant of x is equal to 1 over sine of x. Later on, you'll be able to do a quotient rule and find out that this right here is equal to that. Find out that the derivative of this is equal to that. But right now, it's just important to have these down to memory. So your trig functions, you'll use those a lot in calculus. Calculus, you use trig functions all the time. Stuff like this, you really need to commit to memory. So you can use whatever mnemonic device, you can use whatever you want, as long as you can memorize these. There's also a couple more that I'd like to point out to you. So in calculus, a lot of the times we're using the natural log. So we know that the natural log is log base e, which is the same as ln. So a lot of times we're going to use this natural log ln right here. So you need to know what the derivative, so d dx of ln of x is. So what this is going to be, and again, you'll figure this out later, as long as you can understand that this is going to be 1 over x. That's your derivative of the natural log of x. So the natural log is always going to be 1 over x. There's also one more that's really important. It's super easy too. Let's say you want the derivative of e to the x. So e is Euler's number. A lot of times in calculus we use e, especially because if you do ln of e, this right here is just equal to 1. That's a super good identity to know. That's also, I would remember this before you get into derivatives. Because a lot of times you can simplify some of this stuff. So L to the v is 1, but the derivative of e to the x is the only function in all of calculus that the derivative is equal to itself. So the derivative of e to the x is always going to be e to the x. So this one is awesome. We love that one. Super easy to memorize, and it's super fun to deal with because it makes your questions so much easier. So yeah, I think that that's pretty much it for stuff that you really need to know right now before we get into product rule, quotient rule, things like that. Now, I know some of you all, you may be asking, well, what if we did ln of 2x is equal to what? Or if we said sine of 4x is equal to what? Well, contrary to what you may believe, this right here does not equal 1 over 2x. It's not the same thing. This is something we'll get into here soon. This is called the chain rule. To solve something like this, you would have to use the chain rule. So we know the derivative of sine is cosine, but this is not cosine of 4x. These are not right. So if you get something like this in the future, I'm going to put a video out on it, but it is using the chain rule. So as long as you know the chain rule, you'll be able to solve those. But as of right now, you need to know your basic trig functions. You need to know their derivatives. You need to know the derivative of the natural log of x, the derivative of e to the x, and you will be set for now. Because right now, we have to do the product rule, the quotient rule, the chain rule, all these different things. These are just stuff that you need to have committed to your memory. Another thing too, with trig, so you need to know your trig identities. A lot of times you can simplify your answers using these. So this is the most basic one right here. Hopefully you can remember this from Algebra 2, I think, or maybe even pre-calculus. So sine squared plus cosine squared equals 1. There's two other identities, and the way you get those is by either dividing the entire thing by sine squared of x, or dividing the entire thing by cosine squared of x. So if we divide everything, so this is the basic one. If we divide everything by cosine squared of x, well, we have sine squared over cosine squared, that's tangent squared of x, plus cosine squared over cosine squared, well, that's just going to be 1. And then that equals 1 over cosine squared of x, which we know 1 over cosine is secant. So we have secant squared of x. That's another identity. Now let's say instead we're going to divide everything by sine squared of x. So if we divide this by sine squared of x, we know that's just going to be 1. Cosine squared x over sine squared, well, we know that cosine over sine is tangent. So this is cotangent. 1 plus cotangent squared of x is equal to, well, 1 over sine squared. We know that that's cosecant squared of x. Now, these you probably won't be using for derivatives, but if you get an answer where, you know, you have one of these identities in a numerator or denominator anywhere, you can simplify those into their counterparts. So if you have a sine squared plus cosine squared, that's going to simplify down to 1, and it'll make it a lot easier to work with. So, you know, just a quick little example. Let's say we wanted to find the derivative of, let's say, sine squared plus cosine squared is equal to what? Well, instead of doing the derivative of sine squared and cosine squared, we can just say that this right here is equal to 1. Now we have the derivative of 1, which is equal to 0, because it's a constant, and the derivative of a constant is always 0. So you can see that sometimes just knowing these identities is going to help you out. It's going to make your derivative so much easier, because you won't have to deal with a sine squared or a cosine squared. You're just dealing with 1, and 1 is super easy in derivative form. So yeah, I think that'll be it for this one. My next video should be on the product rule, maybe the quotient rule as well, depending on how it goes. But yeah, this stuff in this video is going to be super important to memorize. It's going to be super important for the rest of your derivatives. Anything you have to do derivative related is going to be really important to know all of these very basic ones. But yeah, that'll be it for now, and I guess I will see you in the next video.